Yes. Well, this little talk is about liquid solar heating systems, solar thermal. And the reason I'm talking to you today is because most of the people doing solar thermal, what they like to install is antifreeze-filled systems where the collectors always have fluid in them. As far as I can tell, they like to do that because they don't want to design the system and they can get the design and the parts all at the same place. And they like to know that what they're doing was designed by an engineer and they don't want to design it themselves. However, antifreeze-based systems are not the best systems. They are the most versatile, but they're not the best. If you can deal with the constraints, there's a much better way to do it. There are some constraints, and that it's called drain back. And the idea here is that if you have your solar collectors, these are water channel solar collectors, if they're high enough, like up on a roof, then, and you have to have the right kind of solar collector. You can't do this with any solar collector. You have to have a solar collector that will drain. But if you get the right kind of solar collector and you mount it up high and can slope your pipes to and from, then you can do what's called a drain back system. And what it consists of is a drain back tank where the water drains back and then the collectors are up above. Now, all you need is a pump to pump the water from the tank through your system up to the collectors, bring it back down into the tank. You pump from the tank through your floor, say, up to the solar collectors, goes through the solar collectors, comes back to the tank. The advantage of this is the system will not freeze and it won't boil in the middle of the day if your power goes out. If the power goes out, once you turn the pump off, you arrange the pipes, and there's some technique here, there's things to know, but you drain the collectors back into the tank, and that's in a heated space, so that there's no pipes with water in them. And that's it. The pump goes off, the collectors drain.
I hadn't thought about that stagnant heating problem.
Oh, yeah, yeah. I mean, I've worked behind systems where the power goes out and then things happen. There are the companies selling solar systems in our area, have been for many years, that are antifreeze based, and their collectors do not drain, and they're very efficient collectors and all that stuff, but this company, Wiesmann, they believe that their collectors will not boil, which may be true in Germany, but it's not true in the San Luis Valley. They use very high pressure, like 50 pounds in their systems, which raises the boiling point of the antifreeze water mixture up to about 300 degrees. The problem is, in the San Luis Valley, this time of year, in the middle of the day, if the power goes out, your collector's going to hit 385, and that's going to boil, and when it boils, it's going to blow all the antifreeze out, and you got to call somebody and get new antifreeze, which costs $100 a 5-gallon bucket. And
they don't tell you this when they sell the system.
No. Well, one of the things I've often suspected, that one of the things plumbers like about these antifreeze systems is that they're pretty high maintenance. The antifreeze can turn acidic if it's stagnated, and over time it turns kind of acidic and has to be flushed and replaced. And that's a good word for the plumber, I guess.
So
requires some specialized equipment, so the homeowner can't do it.
So I would call this not an appropriate technology compared to a drain back. That,
Well, appropriate is a matter of context.
yes, I know, yeah.
And I have built solar systems where part of it was drain back and part of it was antifreeze, where I had a certain amount of roof space and I put up that amount of collectors, but we wanted more collectors, so we put some, next to the wall and ran that part of it on antifreeze. Now, when I do antifreeze, I always put in a very large expansion tank.
Okay.
So that if
yeah.
the collectors boil, there's some place for the fluid to go. In these Viessmann systems, they put in this little expansion tank, which is enough to take the normal heating and cooling of the system, but it's not enough to take the whole volume of the collectors, which is what you need if your collectors boil, because if you boil a collector, it means it's making steam in there and it pushes all the fluid out, and it's going to push it out somewhere through the pressure relief valve, but nowhere else.
I wondered how you dealt with it. Great.
Yeah. So when I encounter a Viessmann system that has lost its antifreeze, I say, okay, we're going to get rid of this expansion tank and we're going to put in a big expansion tank so that when the collectors boil, when they do, because they will eventually, there's some place for the fluid to go. And that makes the systems work better.
Any other comments? Like,
well, I guess the thing about drain back is there are constraints. You can't have your tank and your whatever, your floor, all this stuff that works here and have the collectors here. You got to have the collectors up high so that they can drain.
Sure.
That's the constraint.
Yeah.
And you need a little different equipment. You need this drain back tank, which you can buy drain back tanks. I like to make them. Drain back tanks are, tend to be, in my view, too small. They're stainless steel. They cost $1,200. What I like to do is buy a 30-gallon electric water heater and convert it into a drain back tank. 30-gallon electric water heaters cost, well, depending on the year, I don't know, I haven't priced one lately, but last time I bought one, it was like $350 maybe, and you can do a fair bit of labor for the extra 1,000 that you save.
Now, there through the New Mexico College in Espanola, Northern New Mexico College, there'll be people possibly in developing countries of the world looking at this issue of heating water that can't even consider $350, for an expansion tank, and would probably want
A drain back tank.
a drain back, and want to have a shop put something together.
Drain back tanks can be built. I've had them built. If you build your own, the ones that I've had built, I did some design work. I made it just the way I wanted it. Where the hot water from the collectors comes into the drain back tank. It goes into the tank, and the ones I've designed, I had it go through a pipe and into an elbow at the bottom, so that when it came out, it swirled the tank. And what that does is it puts the water on the outside and the bubbles in the middle, so that when I pull water out of the bottom of the tank, I pull it out at the edge and the bottom. I get good separation, so I'm not pulling bubbles out through, wherever I'm going to go with the water. So building your own tank gives you some flexibility to design things. That allowed me to build a smaller tank. This was for a fairly small mechanical room.
Was the angled part of the pipe perforated pipe, or just no?
That's another thing I've done when I was working with the 30-gallon electric water heater. I'm thinking of a very large system, and the 30-gallon water heater was just barely big enough. But I got these, 2 1-inch pipes blasting water into the drain back tank and stirring it up, making bubbles, and I was getting bubbles out of the bottom of the tank. So what I did was I brought most of the water to where one of the electric elements had been. It's a 1-inch thread, which I made like a manifold in there, a 1-inch pipe with a bunch of holes in the top. So when the water came in, it sort of came out the top of this thing.
Sure.
It wasn't blasting, just like hitting the water in the tank.
Huh, okay.
Full blast. It was pouring out the sides into it. And of course, drain back tanks, where the water comes in the top, you need a little hole so that it drains back. Without the little hole, it won't drain back. But I'm not going to go into all the technical details about drain back tanks. There are some. It's not rocket science, but there are a few things. It's got to drain.
Mm-hmm.
And you don't always need a drain back tank. If you're using a big storage tank, you can just pump out of the storage tank and up there, up to the collectors.
What are your thoughts about batch water heating?
Batch water heating may be the most efficient in terms of resource use. There's no pumps. They're sort of marginally appropriate in extremely cold climates because they tend to lose some heat at night. They're not likely to freeze because they've got a tank up there, and the next day comes around.
And insulated housing.
Yeah, but it's still got the glass on the front.
Yeah.
You got to have the glass on the front, and so they're a little iffy for really cold climates. I know they have been used here in the San Luis Valley, and they work, but the nice thing about them is they don't have much copper in them. Copper's very expensive. It's very expensive to make.
And
it's a lot of energy to make it.
And is it possible to have it drain back? Like have another drum, for example, underneath?
Well, that's a drain back system.
Yeah.
If you're going to pump water through the collector, there's no need to store it in the collector. No need to have a tank in the collector. Cut this part out, Bob. Edit this part.
Okay, I'll use my.
That wasn't really a relevant question. You get my drift.
Oh well, and so okay. Tell me why you couldn't have a batch water heating system that you could guarantee wouldn't freeze.
By draining it at night.
Mm-hmm.
Well, why? What is a batch water heater? It's a tank that's exposed to the sun and typically has a thin copper selective surface adhered to it, right?
Or yeah, I've only used high temperature paint, flat black paint.
Uh-huh. Well, people who manufacture these commercially put like a selective.
Gotcha. Yeah.
And that improves their performance a lot. But why have a tank up there behind glass if you're going to pump to and from it? Just have a collector. You get the water, get the hot water down where you can insulate the tank and all that stuff. Why have the tank on the roof if you're going to pump into it?
There's one reason in my mind, and that is that in some countries I've been in, it'd be very difficult to build a collector for heating liquid. But a 55-gallon drum can be understood and done easily. And so if you could heat a 55-gallon drum, say during the day, maybe 2 times, heat it up to where you can do laundry and then in the evening take showers or something, why not save that hot water down below in an insulated drain back tank?
We'd have to look at the details.
Okay.
I mean, you're talking about the tropics, right?
Yeah.
So don't worry about it.
Don't worry about it freezing, of course. Yeah, I hear you. But we can look at colder climate possibilities with that concept. So I'm not going to edit it out. Oh.
Okay, well, I might demand some editorial,
Oh, you've got it.
if you're gonna put me up there.
Oh, no, you've got 100% editorial right here. I'm not even making any money off of this.
I understand.
Anything else on water?
Well, I think it's a useful distinction between drain back and antifreeze. Drain back comes with a few constraints. If you can meet those constraints, it's definitely preferable, and you won't find your local plumber likely sympathetic. I built a large solar system recently with a plumber who was doing solar systems, and he'd never done a drain back. And while we were working together, I talked to him about drain back, and I said, next time you do a solar system, call me, I'll help you do it. I won't even charge you, I just want to teach you. He's a good guy, I want him to learn how to do drain back systems. And he hasn't called me. I suspect because designing a system is sort of out of his comfort zone. He wants the design to be given to him, and that's what Ferguson offers to their plumbers who shop there.
Yeah, I see.
The whole package.
Mm-hmm.
Of course, there is the caveat, never buy equipment from the people doing the design. Or never buy design work from the people selling you equipment.
Yeah.
It's not a good idea.
Mm.
We learned this at the Baskin Robbins,
Oh, yeah.
where we had a huge solar heating system in a building that didn't need any heat ever.
In Alamosa, Colorado.
Because it was a Baskin Robbins, and they had the whole
Yeah.
issue in the building was getting rid of the heat from the freezers.
Yeah, the condensers, right? And
Yeah,
that's,
it was full of heat-producing equipment,
That's
because the design work was purchased from the people selling the equipment, they said, oh yeah, we're gonna design you a big-ass solar heater for this little building that produces lots of heat all the time. So, anyway, it's always a little iffy, but
right now, that's not a Baskin Robbins, is that correct?
no, it's a coffee shop, I believe.
So now maybe that heating system's
I
doing.
think the heating system is long gone,
Oh. Uh-huh.
the solar heater. I don't think the collectors are out there.
Oh,
I
okay.
think they disappeared, a year into the life of Baskin Robbins.
Okay.